Beneath the tranquil waters of the South China Sea lies a silent threat, one capable of unleashing a disaster unlike anything we've seen before. There are no violent tremors, no roaring volcanoes, just a deep, unrelenting pressure building beneath the Earth's crust. To the millions living along these shores, the sea appears calm and serene. But to geologists, it tells a very different story. One of locked tectonic plates, mounting strain, and a growing threat few truly understand. The Manila Trench, a vast undersea fault stretching 1,000 kilometers, is among the world's least known yet most dangerous subduction zones. It may be one of the most overdue fault systems on Earth, a sleeping giant waiting to rupture. So what happens when a fault this powerful stays silent for too long? What lies beneath this geological stillness? And how close are we to a moment that could reshape an entire region? Today, let's delve into the dangers of the Manila Trench, examining its volatile geology, mysterious history, and the looming danger that could erupt without warning. Don't forget to click on that subscribe button and like this video, as it's the best way to support this channel. The Manila Trench is part of a tectonically volatile zone known as the Philippine Mobile Belt. It extends roughly 1,000 kilometers from southern Taiwan in the north to the island of Mindoro in the south, skirting the western edge of the Philippines' largest island, Luzon. This trench represents a subduction boundary, where the dense oceanic crust of the South China Sea basin, part of the Eurasian plate, is being pushed eastward beneath the lighter Philippine Sea plate. The subduction process occurs at a relatively rapid rate of approximately 5 to 7 centimeters per year, which results in a significant accumulation of tectonic stress over time. What makes the Manila Trench particularly dangerous is its classification as a megathrust fault. These are large, seismically active plate boundaries capable of producing the most powerful earthquakes and tsunamis on Earth. Similar structures include the Nankai Trough in Japan and the Sunda megathrust that triggered the 2004 Indian Ocean tsunami. In the case of the Manila Trench, the interface between the two plates is currently locked, meaning that stress is building up without being released through smaller quakes. When this stress finally overcomes the friction holding the plates together, it is likely to do so in a single devastating rupture. The geological implications of such a rupture are profound. A sudden release of energy along a 600 to 800 kilometer stretch of the trench could displace the seafloor by 10 meters or more, vertically lifting or lowering vast areas of seabed. This type of movement is a primary trigger for tsunamis, as it displaces massive volumes of water almost instantaneously. Furthermore, the trench is part of a complex tectonic network that includes nearby volcanic arcs and transform faults, creating a multi-dimensional hazard zone that extends far beyond the immediate vicinity of the fault. Unlike Japan, which has centuries of detailed seismic records, the Manila Trench has limited historical record due to the lack of early written documentation in the Philippines and surrounding areas. However, geological evidence, particularly uplifted coral terraces along Luzon's western coast, reveals that the region has experienced large, sudden land shifts in the past, consistent with powerful megathrust earthquakes. These terraces suggest vertical uplifts of 2 to 3 meters, the kind of displacement typically associated with earthquakes, exceeding magnitude 8.5. Radiocarbon dating of these formations indicates that major seismic events may recur in intervals ranging from 400 to 600 years. Scattered historical accounts mention earthquakes and tsunamis near the Manila Trench, including a possible tsunami off Mindoro in 1627 and major quakes in 1796 and 1852. However, due to limited scientific data and inconsistent records, it's unclear if the trench was the source. Crucially, the lack of a major rupture in recent times is not a sign of safety. It points to the dangerous possibility that the fault is locked and accumulating stress. In seismology, a quiet fault often signals an impending threat. In recent decades, the Manila Trench region has experienced several moderate earthquakes, but none have released the immense strain building along the main megathrust fault. Notable events, including a magnitude 7.1 earthquake near Mindoro in 1994 and a magnitude 6.2 earthquake in Pangasinan in 2006, caused localized damage but occurred on nearby strike-slip faults or within the subducting slab, not along the main megathrust interface. Their failure to generate tsunamis reinforces the belief that the Manila Trench remains locked and potentially more dangerous. The concern lies not in the immediate impact of these moderate quakes, but in their potential to redistribute stress and bring the trench closer to a major rupture. In December 2024, a swarm of offshore earthquakes near Ilocos Sur, followed by a magnitude 5.6 event near Ilocos Norte, drew renewed scientific attention. Seismic activity has continued into 2025, with smaller quakes indicating ongoing unrest. Seismic and GPS monitoring has also detected slow slip events, gradual fault movements occurring over days or weeks. While these events don't produce immediate shaking, they may indicate growing instability along the fault line. Similar slow slip phenomena have been identified as precursors to major earthquakes in Japan and New Zealand, suggesting that the Manila Trench may be exhibiting early warning signs of a larger event. Seismologists believe that a megathrust earthquake along the Manila Trench is not a question of if, but when. Based on geological data, the accumulated stress along the trench is sufficient to produce an earthquake, with a magnitude between 8.8 and 9.3. A rupture of this scale would be comparable to the 2011 Tohoku earthquake, or the 2004 Indian Ocean tsunami event, both of which caused immense destruction and loss of life. A worst-case scenario involves a rupture extending from southern Taiwan to northern Mindoro, with the seafloor rising or falling by up to 10 meters. This vertical displacement would displace an enormous volume of seawater and generate a tsunami that could reach the western coast of Luzon in as little as 10 to 15 minutes. Cities such as Subic, Dagupan, and parts of Metro Manila would have almost no time to evacuate. The tsunami would then radiate outward across the South China Sea, potentially reaching the coasts of Hong Kong, Macau, southern China, Vietnam, and Malaysia within 2 to 4 hours. Numerical simulations conducted by researchers in Taiwan and Japan show that such a tsunami could produce wave heights exceeding 10 meters along parts of the Philippine coast and up to 5 meters in southern China. Given the high population density and coastal urbanization in these regions, the consequences could be catastrophic. The human cost of a Manila Trench megathrust event could be immense, with tens of millions of people living in low-lying coastal areas throughout the region. A large tsunami would likely cause widespread loss of life, particularly in areas where warning systems and evacuation infrastructure are inadequate. Entire communities could be wiped out within minutes, and many more displaced in the aftermath due to flooding, contamination, and infrastructural collapse. The economic fallout would also be severe. Metro Manila, one of Southeast Asia's largest financial and industrial hubs, could see widespread destruction of infrastructure, including roads, bridges, ports, and power plants. Economic centers in Hong Kong, Shenzhen, and Ho Chi Minh City would be affected both directly and indirectly through port closures, disrupted supply chains, and widespread panic in financial markets. On a geopolitical level, such a disaster would spark a major international humanitarian response and shift regional power dynamics. The South China Sea, already a flashpoint of strategic tension, would become a hub for global relief efforts, drawing in military and civilian resources. Its impact would extend beyond the region. Global markets and industries reliant on Southeast Asian trade would feel its effects for months, if not years. Despite the magnitude of the threat, preparedness for a potential Manila Trench disaster remains inadequate across the region. In the Philippines, the Philippine Institute of Volcanology and Seismology has expanded its seismic and GPS monitoring, but lacks key offshore tools like deep-sea pressure sensors and ocean bottom seismometers, essential for detecting early signs of tectonic strain. Japan has become a key partner in improving monitoring through data sharing and modeling support, yet coverage remains uneven, especially in deeper trench areas and in neighboring countries such as Vietnam and Malaysia. Early warning systems are developing, but face serious gaps. While the Philippines conducts regular drills and has protocols in urban centers, many coastal communities lack communication systems, evacuation plans, or public awareness. China, Taiwan, and Hong Kong have incorporated basic tsunami modeling into civil defense planning, but general awareness is low. Critically, no unified tsunami warning system exists for the South China Sea, leaving millions exposed to a shared, under-recognized risk. The Manila Trench remains one of the most formidable and underappreciated seismic threats in the world. As urban populations in coastal Southeast Asia continue to grow, so too does the scale of potential devastation. While scientists cannot predict the exact timing of a rupture, the geological evidence is clear. The trench is capable of producing a megathrust event, and such an event is likely overdue. In the years ahead, nations around the South China Sea must treat the Manila Trench as a regional security issue. Investments in offshore monitoring infrastructure, public education campaigns, integrated warning systems, and international cooperation will be essential. The technology and knowledge exist. What is needed now is political will, cross-border collaboration, and the recognition that nature does not respect national boundaries. The future may still be unwritten, but the warning signs are loud and clear. The silence of the Manila Trench is not reassurance. It is a call to prepare. With so many lives at risk, the Manila Trench should be treated as a global priority rather than just a regional concern.